solve the initial value problem. So here we go. We have an equation that looks like it's in the form for maybe an exact equation again, and we have our initial condition y when x equals 1 is equal to -2. All right, so let's get going. Let's make sure this is an exact equation before we try and find f of x comma y. All right, so this is Mars of x comma y. Oops. And this piece is Neptune of x comma y. All right, and the test for exact is we want to know if partial Mars, partial y, does that equal partial Neptune, partial x. All right, so partial Mars, partial y, well, that's partial y times, see up here, it's 2x plus 2y, 2x plus 2y. All right, that's not so bad. So the 2x term disappears, there are no y's in it, and then the 2y term turns into 2. So I have 0 plus 2. And then the partial Neptune, partial x, that's partial x applied to almost the same thing. It's just reordered, 2y plus 2x. All right, well, partial x applied to 2y, that's 0. Partial x applied to 2x, that's 2. So the answer was yes. So now we're going to go ahead and try and find f. So the way we can find f here is, right, the way this works out, f of x comma y equals c Mars of x comma y. We can go backwards with an integral with respect to x, and Neptune of x comma y prime equals 0. We can go backwards with an integral with respect to y. All right, so then there are two ways to compute this. We have f of x comma y is equal to the indefinite integral of Mars of x comma y dx. Well, that's the indefinite integral of 2x plus 2y dx. And that's equal to, let's see, 2x will turn into x squared. 2y will turn into 2xy, sorry, the plus. And then plus, we might have some y functions that disappeared, so we're just going to have to add on our h of y. All right, alternatively, we should have this, an equivalent way to get f of x comma y. We should be able to take the integral of Neptune of x comma y with respect to y. Well, that's the integral of, or just a little different here, whatever, but 2y plus 2x dy. All right, well, 2y integral with respect to y, that's going to be y squared, plus 2x integral, that's going to be 2xy, and then we might have a g of x. All right, so looking at both these, I'm going to finish off and write f over here, f of x comma y. Oh, I do need to solve the initial value problem. I'll put it over here. So f of x comma y is equal to, let's see, okay, so y squared and x squared. All right, so the x squared can go with the g of x. The y squared can go with the h of y. So it looks like I have x squared plus 2xy plus y squared will work out. So x squared plus 2xy plus y squared, and that equals a constant. And so now if I want to solve for the initial condition, this y of 1 equals -2, I'm going to plug that in. Now I've got, let's see, 1 squared plus 2 times 1 times -2 plus -2 squared equals c. All right, that's 1 minus 4 plus 4 equals c. So 1 is c. And so the solution to this initial value problem is x squared plus 2xy plus y squared equals 1. And actually, we can simplify this further if we want. This is actually x plus y, the whole thing squared, equals 1.